let us recall some math concept that we learned in high school. The concept of distance between 2 points. So suppose we have 2 points A and B and we locate them on the number line. Then we have two possibilities. We have the case where A is less than B. And this is the case where A is greater than B. So for either of these cases, the distance between 2 points, the distance between A and B is denoted by this symbol. This is a non-negative symbol. Remember, we are only after of the distance between the points. So when we have points or when we have values f of x and a real number L, then the distance between f of x and L is denoted by this symbol. We can also restrict the distance to have a ceiling or a maximum value, something like that. So, like this, the distance between f of x and L is less than epsilon, meaning L or f of x is not far from L by epsilon. We can also restrict the distance to be greater than 0. Remember, the distance is non-negative. It can be positive or 0, but if we want it to be greater than 0, this implies that f of x is not equal to L. Also, by transitivity, this also implies that epsilon is greater than 0. So let me present the formal definition of the limit of a function, or the epsilon delta definition of the limit of a function as x approaches A. So let f of x be defined for all x over an open interval containing A except possibly at A itself. Except possibly at A meaning f of A may not exist. Now suppose we have a real number L, that we can say that the limit as x approaches A of f of x is equal to L if for every epsilon greater than 0 there exists a delta greater than 0, such that if the distance between x and A is greater than 0 and less than delta, then the distance between f of x and L is less than epsilon. Okay, basically the limit of this definition says that the limit of f of x as x approaches A is equal to L if this condition is satisfied. So let's look at these two inequalities, because these are the two major components that the condition needs to satisfy. Okay. So the definition says that if for an arbitrary epsilon, meaning if we can pick any value for epsilon, there exists a delta, meaning we can find a delta such that this condition implies this condition. What does that mean? Such that if this is true, then this is true. Okay. So let's expand this. Let's make this simpler. If we expand that, we get this when we remove the absolute value. Okay. And the same thing for the other one. When we remove the absolute value and we transpose A, we get x between A minus delta and A plus delta. Okay, so this is, what does this mean? This means that f of x is inside the interval L minus epsilon to L plus epsilon. And this part here says that x is in the interval A minus delta to A plus delta. So the definition states that the limit of f of x as x approaches A is equal to L if we are able to find a delta, an epsilon greater than 0, there exists, if for an arbitrary epsilon greater than 0, there exists a delta greater than 0 such that for any x that we pick inside the interval A minus delta to A plus delta implies that its corresponding f of x value would be located in the interval L minus epsilon to L plus epsilon. Okay, so let's try to illustrate the definition wherein f of x is described by this graph, and the limit of f of x as x approaches a is equal to L. You can see this from the graph that it is so, and we want to show that this really satisfies the epsilon delta definition. Okay, so let's pick an arbitrary epsilon and let's form L minus epsilon to L plus epsilon. So this is our interval. Okay, and then it says that if the limit of f of x as x approaches a is equal to L, if for every epsilon we are able to find a delta. Okay, so this is the delta that I was able to find, and this forms a minus delta to a plus delta. It's the interval. Okay, now this band tells us that if we pick a value of x within this interval, within the interval a minus delta to a plus delta, then the corresponding function values would just be within this part here. Okay, or if you look at it on the graph, it is just anywhere on this yellow shaded part of the graph. So what are these points? These are the f of x such that the x's were just taken, or the values of x were just taken anywhere in the interval a minus delta to a plus delta. So the definition says that, okay, by the way, this is the band. This band here, the orange band, is the interval L minus epsilon to L plus epsilon. Okay. Now this was the condition that the definition wants us to satisfy. It says that the limit of f of x as x approaches a is equal to L if this condition is satisfied. Meaning, it says that if you pick any value for epsilon, okay, so you pick any value of epsilon. So, okay, let's make it simple. It says that the limit of f of x as x approaches a is equal to L if, suppose we have an arbitrary value for epsilon, we can find a delta, a value for delta, such that if x is within this interval a minus delta to a plus delta, then the values of f of x would just be also within the interval L minus epsilon to L plus epsilon. Now for the delta that we found, look at where the value of f of x is. It is just a subset of the bigger interval. So indeed, this satisfies the epsilon delta definition. So this shows that indeed the limit of f of x as x approaches a is equal to L.